Hello, and welcome to this lesson about Introduction to Indoor Air Quality and its importance. In this lesson, we're going to talk about what is indoor air quality, why is IAQ important, key indoor air pollutants, and discuss about the sources of IAQ pollutants. The learning objectives are, so in this lesson, should be able to explain the concept of AIQ and identify the key factors that influence air quality in indoor environments. You should recognize and describe the major indoor air pollutants, including particulate matter, volatile organic compounds, biological contaminants, and gaseous pollutants, and discuss the impact of IAQ on health, comfort, and productivity, and the role of HVAC systems in improving air quality. So let's start with a question. Think about a time when you have experienced poor air quality indoors, whether it was in a dusty room, a stuffy office, or somewhere with strong odors. How did it affect your focus, mood, or health? I think this is something that most of us has experienced. We are working on a place, and then we may be are bothered by the odors of the place, and or maybe we feel like there is not enough ventilation and feel like this stuffy air indoors. In my case, this affects the way that I work. It made me uncomfortable, and I think that I am producing less. So all this is a common situation that we are gonna be able to solve by designing a proper HVAC system. So what is indoor air quality? Indoor air quality, or IAQ, is the condition of the air inside buildings, and it is critical because it directly affects the well-being of the occupants. It's not just about clean air. IAQ considers various factors that contribute to making indoor spaces comfortable, healthy to live and work in. Several factors influence IAQ. These include physical aspects like temperature, humidity, and air velocity, which are controlled by HVAC systems. But just as importantly, the presence of pollutants, whether they are particulate matter, volatile organic compounds, or biological contaminants, can significantly affect air quality. Effective ventilation plays a key role in removing contaminants and providing fresh air to improve IAQ. So poor IAQ can lead to a variety of health problems. These include respiratory issues such as asthma, headaches, fatigue, and even more severe conditions over the long term. The presence of certain pollutants like VOCs or mold can exacerbate allergies or trigger asthma attacks, which is why maintaining good indoor air quality is so important. So the key goal of indoor air quality management is to maintain air that promotes good health, supports comfort, and enhances productivity in the environment. Through proper HVAC system designs and ongoing AIQ monitoring, we can create spaces that help occupants feel better and perform better. So why IAQ is important? First and foremost, IAQ directly impacts our health. Poor indoor air quality can cause a range of respiratory issues like asthma, coughing, and shortness of breath. It can also lead to more general symptoms like fatigue, headaches, and even dizziness, especially when people are exposed to poor air quality over time. It also plays a key role in our sense of comfort. When air quality is poor, it can affect thermal comfort, meaning we feel warmer or cooler than we should, and it can make the air feel stuffy or stale. Comfort is not about just temperature, it's about the quality of the air that we breathe. A fresh, clean environment is essential for our overall well-being. The effect of indoor air quality on productivity is another crucial point. Poor air quality has been shown to decrease concentration, reduce cognitive function, and lower overall work performance. In workplaces or schools, people are often spending long hours indoors, Poor indoor air quality can lead to significant absenteeism and decrease in overall productivity. When indoor air quality is consistently poor, the long-term effects can be more serious. Chronic exposure to pollutants like particulate matter or VOCs can increase the risk of long-term health effects, such as cardiovascular disease, lung cancer, and other chronic conditions. So it is not just about comfort today, it's about maintaining health over the long run. This is why IAQ must be a priority in building design and maintenance. So, key indoor air pollutants. Let's start with particulate matter or PM. These are tiny particles like dust, smoke, and even allergens such as pollen that can float in the air. Although they are invisible to the naked eye, they can be inhaled into our lungs, causing respiratory problems, especially for individuals with asthma or allergies. Then we have volatile organic compounds or VOCs. These are gases emitted by everyday products like paints, cleaning agents, and building materials. So VOCs can lead to headaches, nausea, and long-term health effects if exposure is prolonged. Proper ventilation and air filtration are key to reducing VOC level in indoor environments. Biological contaminants are also a significant concern. These include mold, bacteria, viruses, and dust mites, which can thrive in damp and poorly ventilated spaces. These contaminants can cause a variety of health issues, including allergies, infections, and respiratory problems, making it crucial to maintain good air quality and regular cleaning. Finally, we have gaseous pollutants like carbon dioxide, radon, and tobacco. Tobacco smoke can also impact indoor air quality. Carbon dioxide, for example, can accumulate in poorly ventilated spaces and can cause drowsiness and decrease concentration. Radon is a naturally occurring gas that can seep into buildings from the ground, and tobacco smoke, though well known, remains a common source of indoor air pollution. Sources of indoor air quality pollutants. Indoor air pollutants can come from many sources within the building itself. For example, building materials like paints, carpets, and furniture can release volatile organic compounds, VOCs, into the air. We have cleaning products and chemicals also contribute to indoor pollution. These can release gases that degrade air quality, such as ammonia and formaldehyde, which are common in many household cleaners. Tobacco smoke is another significant indoor pollutant. Despite the widespread efforts to limit smoking indoors, it still contributes to poor IAQ in many environments. Biological contaminants like mold, pet dander, and dust mites are also common indoor pollutants. These can cause allergies and respiratory problems, particularly in poorly ventilated spaces. We have also outdoor sources or pollutants. So in addition to the indoor sources, pollutants can come from the outside environment, like outdoor air pollution, like vehicle exhausts from traffic or industrial emissions, can infiltrate buildings, especially if ventilation systems aren't properly filtered. Radon, a naturally occurring radioactive gas, can seep into buildings from the ground. It's a serious concern in certain demographic areas and needs to be monitored. Pollen and dust can also make their way inside through ventilation system, especially during certain seasons, contributing to poor air quality. So we are at the end of our lesson. To finish, let's talk about key takeaways. So indoor air quality significantly impacts occupant health, comfort, and productivity, with a poor IAQ leading to respiratory issues, fatigue, and decreased performance. Key indoor air pollutants include particulate matter, volatile organic compounds, biological contaminants, and gaseous pollutants, all of which can negatively affect air quality. Finally, HVAC systems help maintain good indoor air quality by controlling temperature, humidity, and airflow flow, as well as filtering and removing pollutants from the air. Thank you for hearing this video, and I invite you to continue learning with more topics. You can explore the ASHRAE standards and other relevant guidelines for maintaining optimal indoor air quality in different environments. You can learn more about the recommended ventilation rates, pollutant limits, and how these standards help ensure healthy indoor spaces. I also invite you to dive deeper into the various air filtration technologies used in HVAC systems, such as HEPA filters, UV air purifiers, and electrostatic filters. You can learn how these technologies specifically target pollutants like particulate matter, VOCs, and biological contaminants. Finally, I invite you to investigate the balance between maintaining optimal indoor air quality and achieving energy efficiency in HVAC systems. You can explore strategies for minimizing energy consumption while still ensuring healthy indoor air quality. So thank you for listening to us.